All right, I'm going to try and make today's lesson quick and simple and basic for you so you can get on your way with your other obligations. Our objective today is I understand what negative exponents mean, and I can simplify expressions with both positive and negative exponents. All right, now, according to talking to some people that I talked to during class today, you guys have heard of negative exponents before, and you don't find them too terribly difficult. So let's just look at a little exploration and pattern finding that I like to do when we talk about negative exponents. If you take 2 to the 4th, you know that's 2 times 2 times 2, I know my 2's look funky, times 2, and that is going to equal 2 times 2 is 4, times 2 is 8, times 2 is 16. And if we take 2 to the 3rd, that's 2 times 2 times 2, which is going to give us 8. And 2 squared, I'm not going to write all the 2's out. I hope you know that that's 4. And 2 to the 1st power is 2. Now let's see if we can find a pattern, because a lot of times in math, finding a pattern can make a huge difference to your understanding of a concept. So I'm just going to scooch this 16 over here, this 8 over here. And I ask you, how do you get from 16 to 8? Well, you could subtract 8, but that same rule doesn't work too well to get from 8 to 4. A rule that does work really nicely is divide by 2. 16 divided by 2 gives you 8. 8, if we follow that same pattern, divided by 2 gives you 4. 4 divided by 2 gives you 2. And if we were to continue that pattern to something that has an exponent of 0, using the same base of 2, and I just divide my answer to the previous one by 2 again, 2 divided by 2 gives me 1. All right? And actually, any single number in the whole wide world to the 0 power is going to equal 1. And there are about 3 or 4 different proofs of this, but I think the most simple one is finding the pattern and continuing the pattern. Well, let's go ahead and take that one step further. If we divide by 2 again, 1 divided by 2. 1 over 2, because all a fraction bar is division, guys. And you could do 1 divided by 2 and do your long division with it, and you would end up with 0.5. And then you might say, oh, well, that's just the fraction 1/2. But really, 1 divided by 2, you can just put 1/2. All right, that was a little side topic. Sorry, I'll stay more focused this time. If I continue the pattern again, and I divide by 2 again, I'm going to have to take 1/2 divided by 2. If you know anything about fractions, if you remember what we've done with fractions, 1/2 divided by 2, you can take it and do leave it, change it, flip it. Hope you remember that. The first fraction you leave, you change division to multiplication, and then you're going to flip this second number. Now, I know that all whole numbers can be written as the whole number over 1, so if I flip that for leave it, change it, flip it, I'm going to end up with 1/2 times 1/2. So down here, 2 to the negative second power is 1 over 4. Okay? Another way, though, that you can write it is you can multiply your numerators to get 1, and then multiply your denominators. That gives you 2 times 2, and we can rewrite that as 1 over 2 squared. Are you with me so far? All right, if we look here, we started out with 2 to the negative second power. And we ended up with an answer of 1 over 2 to the second power. There seems to be some kind of connection between the denominator here and our base and exponent here. Let's see if that continues. If I have 2 to the negative third, okay, well now I'm taking 1 over 2 squared, and I'm going to divide it by 2 once again. So if I divide that by 2, hang on, extend my page to give me some more room. It's really 1 over 2 squared times the reciprocal of 2, or the opposite of 2, is 1/2. And if I do that multiplication, 1 times 1 is 1. 2 squared times 2, guys, that's just 2 to the third power, 2 cubed. So my answer here is 1 over 2 cubed. Once again, I started out with 2 to the negative 3 power, and I ended up with 1 over 2 to the 3 power. So we can decide, excuse me, sorry. We can say that certain rules exist for negative exponents. I'm just skipping around, guys, here to make the video a little bit shorter for you. So for any non-zero number a, so as long as your base isn't 0, if we have a to the negative n, we can say that's just 1 over a to the n. This negative exponent tells us that we have to take our original power and put it down to the bottom of a fraction. So if, for example, we have 7 to the negative 4th, we're going to put it to the bottom of a fraction, and it's going to be 7 to the 4th. The negative kind of disappears and sends it to the bottom, says 7 to the 4th to the bottom of a fraction. Try this one on your own real quick. What you should have gotten is 1 over 36 to the positive 8th power. The negative tells us it goes at the bottom of the fraction, and the power becomes positive, so it's just 8 instead of negative 8. One more. Try that one, see what you can get. And we should end up with 1 over 439 to the 3rd power. Now, you can do this kind of work with variables as well. So here I have y to the 4th power. Just like with all of the other ones, it becomes at the bottom of the fraction, and it becomes y to the positive 4th power. Okay, a variable is just like a regular number. You do the same kind of thing. Okay, so this understanding of negative exponents can also be used in other situations. And I'm going to work through these first 2 examples here, and then this third one is going to be your reflection question for tonight. I want to see what you can come up with it. It's a little challenging. So if we look at this first example, 2 to the negative 3rd over 2 to the 4th, we know for our rules of division, dividing 2 numbers with exponents for division, you have to subtract the exponents. So my answer is going to end up being 2, but then I have to do negative 3 minus 4. Is it any wonder we just spent some time working on integers? Because you guys need this understanding of integers when you do every unit from here on forward. So negative 3 minus 4 is negative 3 plus negative 4, which gives you negative 7. So our 2 now is going to have an exponent of negative 7. But what does a negative exponent tell us to do? It tells us that we have to put this as a fraction with 2 to the 7th on the bottom. The negative exponent sends it to the bottom of a fraction. If we look again at another kind of problem, that big square in the middle is supposed to be a multiplication sign, guys. Sorry, it's kind of weird looking. But we're going to apply our same rules of exponents that we've been doing, just now we have negatives. So we have 5 to the negative 8th times 5 to the negative 7th, and hopefully you remember that when you're multiplying 2 numbers with the same base, you can simply add the exponents. So this is going to become 5 to the negative 8 plus negative 7 power. That is going to give us 5 to the negative 15th power. And since most math people like to not have negative exponents in their final answer, you are going to take this. That negative exponent tells you that 5 has to go on the bottom of a fraction, so it becomes 1 over 5 to the 15th. All right, guys, I know this was just a quick review of negative exponents. I want to see what you can do. Try out this problem here. I know there aren't any negative exponents right now as it is, but here's a big hint. Your as you're working through the process of simplifying this, you might end up with a negative exponent. And I want to see if you can come up with the correct answer for this. So when you turn in this homework assignment, type in that response and try and answer this question, and I'll give you some feedback on whether or not you got it. Thanks, guys. Have a good one.